Welcome back. In this video, we'll be looking in more depth into finding areas under the curves or areas under the functions graph, in other words. So, we have these two limits that we substitute, and it's such that we said this is we putting the value of b in, substituting that into the integral, we're finding all this area here, and then we substituting the value of a, and we subtracting this area, so we end up with the area only between a and b. All right, nothing else. The upper limit and lower limit of the integral, where a is here and b is here. Okay, so f of x would be here and dx would be like so. Okay, so in this example, we have been given a constant that's missing uh, in the integral called p, and then we've been told the result of the integral is 4p squared. Show that there are two possible values of p and find them. So first, we just using the power rule, we add 1 to the power and we divide by the new power. So we will get rid of the 2 in front of p, like so, and this 7 becomes 7x. We substitute the upper and lower limit. We write 25p squared plus 35 minus p squared plus 7. We simplify that and we get this. So that's a 35 and this is a 7. We subtracting the 7, we get 28, and 25 is p minus p is going to be 24p. Now we've been told the answer to the integral is 4p squared. So what we're going to get is we're going to write 4 equal to 4p squared, and we can rearrange this equation and set it equal to 0 to make it a quadratic, and by writing it like so, and then we can factorize maybe even divided by everything by 4 to simplify it, and then we try to factorize it. The factors are easy to see. It's minus 7 inside the bracket plus 1, and outside of the bracket these are the values for p. That's it. We've answered the question. It's an abstract question. There is not much to interpret about it. Okay, so we are finding the area under the definite integral when we have limits here. So we are finding, notice that we are finding the area between the under the curve up to x-axis. Okay, so yes, there are cases where you actually have a function like so, and if you evaluate it between a and b here, the area under the axis, under the x-axis, all right, we will discuss that in the next exercise, is going to come out as a negative area. So we'll deal with those examples later. This area will turn out to be negative. Sometimes, so the area is automatically bounded by the x-axis here. All right, that's what we say. So that's the graph for this function y equals to 20 minus x squared. And what we are going to do is find the area above the x-axis bounded by the curve. So we know its roots when you factorize this expression is already 4 and minus 5. The graph is already telling us that. That's why we are putting those values. If you didn't know them, the the question didn't start with the graph. I already put it there to you because I really, the initial step of the equation was to factorize this. If you unsure how did we factorize it, you can factor out a minus sign and write here x squared plus x minus 20 and factorize this. What you end up with is x plus 5 and x minus 4 here. All right. Then because of the minus in front, because this is equal, we're setting this equals to 0. Actually, uh, well, you can ignore the minus at the front. The roots will be the same, and x will be minus 5 and x will be 4. That's just saying that the graph is upside down. Okay, it's the upside down of this curve here. All right, rather than having an intercept of minus 20, it has intercept of positive 20. All right, so then after that, we are putting those roots on top and bottom of the integral there as limits, and we are evaluating this integral with the power rule, and we are simply just substituting 4 into the function and subtracting minus 5 substituted into the function. We end up with this value, which is a positive number. Okay, so for exercise 13E, that's enough, and I'll see you in the next section where I'll show you the areas under the x-axis.